Okay, the first thing we want to do is sketch this. We want to sketch this point on that circle. Where is the center of that circle? Where's the center of that circle? Remember this format, x minus h squared plus y minus k squared equals r squared. So the center is at 0, 0, and the radius is 1. So sketch that. What's another name for this circle? The unit circle, okay? And we have the point 8/17, comma 15/17 on it somewhere. So that's the point 8/15. Oh no, 8/17, I'm sorry. 8/17, comma 15/17. So anytime we have a point on the unit circle, what do we always do? Make a triangle. So your terminal ray goes right there. We drop the altitude down. We have the base. Okay? So how long is this, Molly? How many units long? No, well this is only 1, so that could not be 17. Look at your coordinates and how I got out here. To get to that point, how many coordinates over did I have to go? No. Look at my coordinates. To get over here, let me change this. If I'm going to point 5, 7, how many coordinates over do I have to go? To plot the point 5, 7, what's my x-coordinate? 5. So I have to go over 1, 2, 3, 4, 5, which would make that 5. And I have to go up how many? 7. 1, 2, 3, 4, 5, 6, 7 to get to my point, which would make that 7, which gives you the dimensions of your triangle. Yes? So to get to 8/17, comma 15/17, how many do I have to go over first? This is 1, dear. 8 would be way the heck out here. You go out as much as your x-coordinate tells you to go out. So what's my x-coordinate? 8/17. So I'm going over 8/17. Does that make sense? Okay. And then how many am I going up? 15. Yeah, 15/17. Good. And then what is my hypotenuse, Jake?
1.
Very good. Yep. So the question on this says, what Pythagorean triple? First of all, do we know our Pythagorean triples? Raise your hand if you know a Pythagorean triple, or even what that is. I'm not sure how much they teach that in geometry. What do you think, Jake Clancy?
5, 12, and 13.
5, 12, 13 is one? So that's not necessarily this one, but 5, 12, 13. A Pythagorean triple is 3 whole numbers that make a perfect right triangle. So they'll satisfy 5 squared plus 12 squared equals 13 squared. They'll satisfy the Pythagorean theorem. There's a 3, 4, 5. There's an 8, 15, 17. And guess what? That's what this one is. Okay? So what Pythagorean triple is associated with this point? It's the 8, 15, 17. And then use the equation of the circle to prove that this point is on the circle. If I want to prove that this point is on the circle, I essentially, let me get rid of this little side sketch here that we didn't really need. I need to prove, how do I prove that a point is on the equation of a circle, or on the equation of anything? How do you check to see if this point is on this graph? Plug it in. So I'm going to do 8 over 17 squared plus 15 over 17 squared equals 1. Now, 8 over 17 squared is going to be 64 over 289. 15 over 17 squared is 225 over 289. And then the good news for me is I already have a common denominator, so 64 plus 225 is 289 over 289 equals 1. And can we put a check mark and confirm that that's true? Good? Okay. So we're going to jump to starting those test 3 questions that we're not going to get to, obviously, via homework. You're going to get through to 1 through 10, and you're going to get through 11 to 20. But starting with number 21 on test 3. I'm not there yet, Jake. Write 2 plus I cubed in standard A plus BI form. What do I do, Chance? You have to just simplify it out. 2 plus I times 2 plus I times 2 plus I. Very good. Now, whenever you're multiplying 3 things, you want to start with the first 2. We'll hit up that third one in a little bit. So, but 2 times 2 is 4, plus 2i, plus another 2i, plus I squared. Tell me, what do you know about I squared? It's negative 1. So when I have to combine a 4 with a negative 1, and that combines to be a 3. I'm combining, not multiplying. It's going to be 4 minus 1, which is 3. And then how many i's do I have total? 4i. So that's my first 2 terms, plus I still have to multiply it by this third 2 plus I. Good? FOIL, 3 times 2 is 6, plus 3i, plus 8i, plus 4i squared. And tell me again, what's going to happen to this plus 4i squared? Minus 4. So 6 minus 4 leaves me with 2, and 3i plus 8i is 11i. And they said A plus BI form. Do I have it in the right order? I do. Your A is your constant 2, and your BI is your 11i. So this is your final answer, 2 plus 11i. And which one is that? Which option? Option 1. Good. Okay? Let's look at number 22. Which recursive definition models the growth of a one-time investment of $6,000 in a bank account with a yearly interest rate of 3% compounded monthly? Okay, one of your flashcards is the compound interest formula. Your final amount is given by your initial amount times 1 plus your rate over n, raised to the n times t power. Now this isn't going to be an exact match for this because they're asking you to write this one recursively. If you look at all of your options, they all start with a first term, your beginning term a sub 0 of 6,000, which makes sense because that was your one-time investment. Okay? Your yearly interest rate is 3% compounded monthly. Which one of these shows 3% compounded monthly, kind of wrapping this idea up into it? Option 1, right? Option 1 is saying take the year before and increase it by 3% divided into 12 parts, because that 3% growth is divided monthly 12 times in that year. Okay? So it is option 1. Option 4 didn't change the percent to a decimal. Option 3 didn't compound it into 12 parts. And I'm not sure what option 2 did at all. Option 2 might be that continuous compounding method, like the PERT formula, right? Your principal e to the RT, so that's not for this either. Okay, your homework again, like I said, test number 3, and we're on to, back to the first set of numbers. This is all online. The solutions are there.